Hello, in this video, I will explain step by step on to use the node voltage method to find V1 and V2. So our goal here is to find V1 and V2. V1 and V2. And we will use the node voltage method. Okay, let's see what can we get from here. Node voltage method. Okay, the first step that we need to do is label all the nodes. Label all the nodes. Let's see what can we get from here. And also beside labeling all the nodes, we also extract all the available information from the circuit here. Okay, let's see from the circuit here. Let's set our bottommost node here as our ground. So we will have this here as our reference node, or some other books call it ground, but it is exactly the same, which is the voltage in this node here is 0, right? Okay, and let's see the nodes in the circuit. I see this node here, and let's name this node as A, so the voltage here will be VA. And then we will have this node here, and I name this node here as VB. Why this is not a node? Because it is connected directly to this, so this is actually not VB2, right? So all these cables here, right? So we only have two essential nodes in this circuit. I mean three essential nodes, but one of them is reference node that we know that the voltage there is 0. So we have done the first step, which is labeling all the nodes. And then the second one will be assume the current direction. Let's see, assume the currents direction. And for the branch with current source, I just follow the arrow here. So this will goes up and eventually it will goes to the right, right? So we will have it like this. And here, this is going down here, or from here, it will goes to the right like this. But then for the other components, we can assume it arbitrarily, but I usually assume the current is going down for the vertical component like this. 1, 2, and 3. Here, all going down. And for the horizontal component, I usually assume it goes to the right, right? And I think we have labeled all the current assumption direction. Yeah, we have done all of the branch. And then the third step will be do KCL for all unknown non-reference node. So we need to do KCL at VA and also KCL at VB. Okay, let's do KCL at VA here. See, let's do KCL at node VA. And KCL said that the sum of the current that goes in will equal to the sum of the current that goes out, right? And here, the only current that goes in is this current here. But we know that is a current source, so it is fixed. So we will have 6 ampere there. Good. But then what else? We have this current here that is going out. But we don't know the current yet, but we can use Ohm's law for that, right? And the current comes from node VA, so I will write VA first. And the current goes to the ground, so I will have -0. But this is voltage, we need current. To get current from voltage, we need to divide it by the resistance between them. So I will have 40 here. Good. And now we move on to this current here. And the current originating from VA, so I will have VA here, and then the current goes to VB, so I will subtract VB from it. Again, to get the current, we need to divide it by the resistance between them, so I will have 8 here. Good. Now we can multiply both sides by 40 to get rid of the denominator, right? 6 multiplied by 40, that will be 240. And then 40 and 40 will cancel each other, so it's left with VA minus 0, but VA minus 0 is just VA. And here 8 and 40 will cancel into 5, so I will have plus 5 VA and then minus 5 VB. Good. And 1 plus 5, that will be 6 VA. And then minus 5 VB. And that will equal to 240. And I think this is our first equation. So we'll have this as our first equation here. So we will have 6 VA minus 5 VB is equal to 240. Good. But we have two variables. We need one more equation. We need two equations to be able to solve it, which is can be obtained by using KCL at VB here. Okay, let's calculate that. Let's do another KCL at VB. KCL at VB. KCL said that the sum of the current that goes in is equal to the sum of the current that goes out. Okay, let's see here. The only current that goes in is from this current here. So the current comes from VA and the current goes to VB. So I will have VA minus VB. And remember, we need current, so we divide it by the resistance between them, 8. And then here we will have the current that goes out, 1, 2, and 3. But for this one, I will have VB, where the current comes from. And then the current goes to the ground, so I will have minus 0 here. This is voltage, so to get current, we divide it by this. So I will have 80 on the denominator. Again, let's play same game here. So I will have VB minus 0, right? The current comes from node VB, and the current goes to the reference node. And divided by the resistance between them, which is 120. Good. And then one more, I will have a current source, which is 1 ampere there. So I will have 1 here. Okay. What can we do here? I think we can multiply this by 120, right? To cancel out all the denominator here. Okay, 8 and 120 will cancel into 15, right? If I'm not wrong. Yeah, 15. So I will have 15 VA minus 15 VB. Good. Oh, I think 80 and 120 is not a factor. So I think we will multiply it by 240 for more factor. So 8 and 240 will cancel into 30. So I will have 30 VA and then minus 30 VB. Good. And then 80 and 240 will cancel into 3. So I will have 3 VB. And then we will have 120 multiplied by, this will cancel into 2, right? So we will have this canceled into 2. So we will have plus 2 VB. And that will 1 multiplied by 240, I will have 240. And so we can have 30 VA and then minus 35 VB and that will equal to 240. Good. Yeah, I think that is good. So we will have 30 VA minus 35 VB is equal to 240. We have two equations and two variables. We need to solve them, which is exactly what is the fourth step R. So we need to solve the equation. Okay, let's clean up this first. Okay, now we have two equations with two variables, and I will do high school math to solve this, right? So we will have this multiplied by 5 to get this to be 30, right? So that will cancel with this, and this one will be 1 here. Okay, now we will have 30, and then minus, 30 VA, 30 VA, and then minus 25 VB, and then 240 multiplied by 5, that will be 1200, and then we will have 30 VA, and then minus 35 VB, and that will be 240. Good. Now let's subtract that, so that we cancel the VA term here, but then we left it with 10 VB, and that will equal to, I think that will be 960. So we will have VB here is 96 volt. Okay, but then we need to find out what is VA here. So we can plug this 96 into this one. So we will have 6 VA minus 5 multiplied by 96, and then that will equal to 240. So I will have 6 VA is equal to 240 plus 5 multiplied by 96. But then I will have our VA here. I think this is the task of our calculator, right? So we will have VA is 240 plus 5 multiplied by 96 divided by 6. And that will be 120. Good. We have now our VA here and our VB here. Right? So VA is 120 and VB is 96. So let's rewrite that. So we will have VA here is 120 volt and VB is 96. However, the question does not ask about VA or VB, but V1 and V2. We need to do one more step. So we need to calculate V1, right? V1. What is V1? V1 is the difference between this node and this node here. So V1 is VA minus the reference node, which is 0. But then that means that V1 is equal to VA, and therefore V1 there is 120 volt. Good. And then what is V2? The same case here. V2 is the difference between this node here, which is VB, and then this node here. But this node is connected to the ground, so I'll have minus 0. So that will equal to VB, and that means that V2 is equal to VB, which is 96. And the unit here will be in volt. And I think that is the final answer for this problem. Hopefully I did not make any mistakes in my calculation. Thank you for watching. See you in the next video. Bye bye.